I'm a 4.0 pre-med, and one thing about me is I study smarter, not harder. Today we're going to be talking about RNS configuration, so let's get into it. I know RNS is something kind of tricky, okay? Been there, done that. And honestly, I could never see it. Like, my professor was amazing, but she could visualize it. Obviously, she's a chemist, right? And so I couldn't. For the life of me, I could not. So she showed me a trick, and that's the trick that I'm going to show with you guys today. So I literally do it just by the priorities numerically and the swapping method, which I'll show you later. And so I could never visualize it. Like, no, I did not buy the models or whatever, the one with like the little ball and stick that you like put it together, like molecular models. No, I didn't do that. I didn't buy that. Like I said, I'm a student, so heck no. So I literally just, did the method. But let's get into it. So the ground rules is that you have to assign priorities. So for example, if I tell you a hydrogen versus a bromine, no kidding, bromine is atomic number 35, so go check out your periodic table for that. And so it's going to definitely have a higher atomic number than for even hydrogen, for even chlorine, for example. And so, yeah, highest atomic number is number 1. But the second thing that you have to notice is that you have to compare what each atom is attached to. So for example, and I'm going to even show you. So this carbon is attached to an oxygen, but not only is it just attached, it's double bonded. So it acts like it kind of has 2 bonds, or is it attached to 2 oxygens, like 2 single bonds to an oxygen. So this is attached to an oxygen, but it's only 1. So this carbon is acting like it's attached twice. So this carbon is going to have priority because it's attached 2 times and this is attached 1 time. So like I said, you treat a double bond as if it's attached 2 times. If you treat a triple bond like it's attached 3 times. So you should get the point, right? If I have, for example, to reiterate, compare what each atom is attached to, if that didn't make sense to you. So let's say I have a CH2 and then I have a CH2, CH3. Actually, this is just, it's not working today. Okay. Let's just say you have a CH3. Okay. So it's not the fact that, okay, it's 3 hydrogen, obviously. No, it's because if you look at it like here, and I know that wasn't the prettiest hydrogens, but you'll get the point. So this carbon is attached to another carbon, and this is just attached to 3 hydrogens. So I'm literally looking at the attachment at this point. So that's why it's a higher priority. Great. Okay. Sometimes this thing is annoying, but just want to get rid of the hot mess. Okay. So that is how you're going to find the priorities. So in this example that I showed you here, this is the highest priority because again, it's acting like it's double bonded. So it is like attached 2 times to an oxygen. The alcohol, on the other hand, the carbon is only attached 1 time to the oxygen. And the methyl group that you have is attached to only hydrogens. And then number 4 is just a hydrogen. Here's another example. So I told you before that the bromine is a higher priority because it has a higher atomic number than is chlorine, then is the methyl group, and then is the hydrogen. So I'm not looking at how big the group is. Like, you can argue with me and say, well, the methyl is bigger. We're not talking about bigger in that sense. We're looking at the first atom. So the chlorine, the carbon, the bromine, and the hydrogen. You're looking at the first thing. And then if you have a tie, like I showed you the last time, like you have a CH2, CH3, and a CH3, then you see, oh, well, the ethane the first carbon is attached to another carbon. Whether it's the methyl group, it's not attached to another carbon. That's what you're looking at. That's the nitty-gritty of it. And the other thing is like the alcohol. I showed you, okay, this carbon is attached to an alcohol, and this other carbon is double bonded to an oxygen. So it's bonded like 2 times to the oxygen. So that's what it is. Okay, so I have these examples for you. And I know I kind of label them RNS. But I want to walk you through it. So don't just cheat and take a photo and then like, oh, okay, I got it. No, actually practice this. This is for your benefit, not mine. I already passed the class, made an A in both. So like, honestly, this is just for you guys. So let's walk over it and do it together. So before I like show you, I want to make a side note. So my side note is this. If you have like here, the 1, 2, 3, 4, if it's going this way, it looks like an R, so that's R. If it's going this way, it looks like an S, so it's S. But that's not the only thing. 4 has to be in the back. If 4 is in the back, your configuration is good. If 4 is in the front, then your configuration swaps. And if it's not like, if it's like here, that you're like, well, hydrogen isn't in the front, it's not in the back, then you have to do what I call the swapping method. So what is the swapping method? So let's get into it. So we know that this is priority 1, this is priority 2, this is priority 3. That was an ugly 3. This is number 4. Well, I'm going to imagine that this hydrogen is going to be in the back, and this one is just a regular line. And then when I do it, I'm like 1, 2, 3, looks like an R. But since I swapped the configuration, this is actually an S. And therefore, this is an R. Okay? If that didn't make sense to you, what we have practice problems at the bottom. That's what we're going to be doing right now. So again, you have 1, 2, 3. So it looks like it's going to be an R, but 4 is in the front, so it's going to be an S. So bold is front, okay? Just FYI, and dashed is in the back. Okay. Well, what about this one around? So ignore the green for a second. If you look at it, this, just ignore that for a second. And this. So you have 1, 2, 3, 4, but you don't have 4 in the front or the back. So what are you going to do? That's what I did in green. You're going to swap the 1 and the 4, and the 1 is going to be in dash. So then it's going to look like, okay, 1, 2, 3. You're going to look like you're going to be an R, but since you swapped the configuration, it's going to be an S. Okay, now let's go to the next one. So then here you have 1, 2, 3, 4. So it looks like it's going to be an S, but the 4 is in the front, so it's going to be an R. Now let's do this one. 1, 2, 3. It looks like it's going to be an R. And it is an R because the 4 is in the back. I'm on this one, you guys. Okay, next one. Well, what about this? You have 1, 1, 2, 3. Oh, but you don't have 4 anywhere. So I'm going to swap 4 and 3. So then it's going to be 1, 2, 3. It's going to look like an S. But since I swapped the 2 groups, it's going to be an R. Again, I feel like sometimes I'm saying things, but maybe you guys don't get it. So let's say I have 1, 2, 3. Because remember, 3 is over here. It looks S, but since I swapped these 2 groups, it's going to be an R. Okay, we're at the home stretch. Okay, so you have 1, 2, 3, 4. It looks like it's going to be an S, but the 4 is in the front, so it's an R. Then you have 1, 2, 3. It looks like an R, but the 4 is in the front, so it's an S. And then you have 1, 2, 3, 4. You have to swap, because remember 4 is not anywhere. So swap 4 and 2. It looks like it's going to be R, but you swap the groups, so it's an S. And that makes it super easy. Okay, so in the next video, sneak peek, I'm going to show you how to apply RNS configurations to molecules. So like R, bromo, whatever, like that type of applying to the molecules to naming. Again, if you enjoyed these videos, I have more. So like I said in the beginning, I'm a pre-med student. And so I've taken a lot of classes. So I have playlists on all those classes on biochemistry, on anatomy, on general chemistry, organic chemistry, etc. So go check those out on YouTube and follow me here and on YouTube. And thanks again for watching.